In this video, I shall tell the story of the amazing mangroves and their fascinating abilities. I will also tell how to recognize the four main trees, the red, black, white and green mangrove.
In the Caribbean beaches, there is often long periods of drought. All the trees are fighting for the little rainwater there is. There's one type of trees that solve all this. They have learned to drink the salt water from the sea, the mangroves.
They cover the beaches and the marshland wherever there is mud. Sometimes it looks like they have stolen our beaches and converted them to mud, but that is not the case. The mangroves need mud to grow. The mud was there first. But when they are established, the mangroves stop the mud drifting by and expands the land with more mud and peat for the trees farther in, so that the black, the white and the green mangroves can grow.
And in doing so, they remove the silt from the water and makes the water cleaner for the corals outside. The mangroves are a mesh of roots and branches and trunks. The trees themselves bind enormous amounts of carbon, and in addition binds carbon in peat. They are important for the climate. Then they serve as breakwaters and protect the coastland from being washed away by waves in hurricanes. And they supply an nourishing ground for a multitude of small fish that lives a protected life among the roots. And of course, it is the birds and frogs and other wildlife ashore. The mangroves are the frontier soldiers of the tropical forest towards the ocean, and foremost of all is the red mangrove. That is the tree that reaches farthest out on the deepest water. It may look like an insignificant scrub, but in reality it is an amazing tree. It walks, it gives birth to live children, it can grow to amazing heights, but first of all it can survive on salt Caribbean ocean water alone. And that is not a small feat. Humans have actually learned from the red mangrove how to make fresh water out of salt water. In the roots of the red mangrove there is a membrane that separates the salt water outside and the fresh water inside. Salt won't get through that membrane, and it has been possible for humans to make a membrane like that. So in water makers, you force salt water through that membrane and get fresh water on the other side. But the force necessary to do that is very strong. It's equivalent to lifting the water 260 meters high. So if you would imagine a tree 260 meters up in the mountain with roots down by the water side, so you have to suck the water all the way up before it can start to drink. That's equivalent to what the mangroves do when they drink salt water. That's pretty amazing. The power here is enough to drive a power plant, for instance. When a river runs out in the salt water, actually you waste a lot of power. You can have a power plant that uses that energy in fresh water and make electricity. But it's not economic. Too bad. For the red mangroves, if it grows a place where there's brackish water instead of salt water like here, and where there are no hurricanes to tear it down, it can grow amazingly high, more than 60 meters. In Gabon, a red mangrove of the height of 65 meters grows in the rivers. Imagine that, a scrub here, a giant there, the same tree. The red mangrove is called a walking tree. While other trees grow up from a root firmly stuck in the ground, the red mangrove make new roots all the time. Far out on the branches, the root can start. It can grow starting as a thin vertical straight trunk and grows thicker the further down it comes. When it hits water, it branches out
and when it reaches the bottom, it grows solid roots, and it is still part of the old tree. Another way to expand is to grow the roots away from the tree. When the far roots are established in the water, new trunks can grow on top of them. One tree can thus grow new roots and new trunks away from the original trunk, that often withers and die. The expanded roots can serve as protection for the young kids from the tree, because the red mangrove gives birth to live children. The seed never leaves the tree. It germinates and grows to become a little baby tree before it finally leaves its mother tree. It is shaped like a spear and can plant itself in the mud just under the branch it's germinated on. Or it can fall in deeper water. Then it floats horizontally and can reach new shores far away. Up to 1 year it can be floating before it feels that it has come to a good place. Then the root part grows heavy, and the tree child sinks to the bottom root first to plant itself. And if the new place is not to the baby tree's liking, it can rise to the surface again, float horizontally, and keep searching for a better place. I have never heard about any other tree that can do something like that. There are 4 types of mangroves that are common in the Caribbean waters: the red, black, white and green mangrove. They are all different families, even if they look alike. Behind the red mangrove, on more shallow water, is the preferred place for the black mangrove. It also gives birth to live children. These children are shorter and will wash farther up on the beach. Behind the black mangrove is the white. It has even shorter and rounded children. The green mangrove is on dry land most of the time and has seeds like normal trees. The black, white and green mangrove do not have the ability of the red mangrove roots to filter out salt water. They drink what they get and expels the salt afterwards on the leaves. But of course, they also must make fresh water for themselves. The work is the same even if they do it internally rather than at the border. The rest of the time we shall devote to a little course in how to recognize the 4 mangroves. That is not straightforward, as they are strikingly equal. That is the mangrove you can see by the leathery leaves and the place they grow, near or in the sea. We shall take a trip to one of my favorite beaches. This is one of my favorite beaches. And the reason is, here we have all the 4 mangroves side by side. This of course is the red mangrove. You can see that because of the prop roots. But let's have a closer look at the leaves. They are lens-shaped as they are supposed to be. They are leathery and they are darker on the top side than the underside, which is lighter. That's correct. And then you have this continuous from the leaf to the stalk. There's no clear difference, and that's important. Then the leaves come in pairs in here, and these 2 they belong to each other. These belongs to each other. These belongs to each other. And then there are a little maverick here. That's also pretty common. But the general principle, they come in pairs. And the next general principle is that all the leaves are at the end of the branch, and that is typical for the red mangrove. Here we have a propagule, a small child red mangrove, quite ready to start the voyage out to the ocean, or maybe just get stuck in the mud here. This is typical also for the red mangrove. It's the only one that has these long propagules. Just beside it we have this tree, and we got a little warning that this is the black mangrove, looking at the roots here. These are pneumatophores. They are supposed to suck air down to the roots. If we compare the leaves from the red mangrove to the black mangrove, they are not very much different. It's a bit lighter, it's a bit smaller on the black. This is the black, this is the red. They also have this continuous transition from leaf to leaf stalk. You cannot see where the leaf starts and when the stalk begins. Then they also come in pairs, two here. Let's see, two leaves here, two leaves here, two leaves here. So what's the difference between this one and red? The difference is that the leaves are not clustered at the end of the branch. For the black mangrove, the leaves are distributed all over the branch. Then we come to this tree, and it looks like the black and the red at first glance. But this is white mangrove. So how do you know that? Because the white is a little tricky. It can have prop roots like the red mangrove. It very usually have pneumatophores like the black mangrove, and it also can have buttons like the green mangrove. But it's one thing that distinguishes it. The leaves here are smaller, but again, it's difficult to see if you just have one tree, if this is small or big leaves. But the real difference here is the transition from leaf to leaf stalk, because here is clearly this is leaf and this is leaf stalk. You can see in all the leaves they cut right off. It's not continuous. There's also two small sugar glands at the end here. This is then the green mangrove. And how do you know that? Yeah, they have also. Actually, here it's not difficult to see because you see all these small buttons. That's why it's called buttonwood. It's the most common name. But if you don't have any buttons, what you should look for is how the leaves are arranged. Because here the leaves are single. They're not pairs like all the others. Here the leaves are single. One here, one there, one there. That alternate position on the ground. As the wood material goes, mangroves are hard, strong and durable. But it is difficult to get long straight timbers. The red mangrove has a beautiful wood. The black is special in that the sapwood is harder and stronger than the core wood. It's so heavy that it sinks in water, even when dried. So, to sum up, if you want to identify a mangrove, look at the leaves. If they are alternate, not pairs, it's green. Look for the buttons. If it has distinct transition from leaf to stalk, it is white. Look for the sugar glands. If the leaves are clustered at the end of the branch, it is red. Look for the prop roots. If neither of these, it is black. Look for the pneumatophores. I hope you have enjoyed this short trip to the mangroves. Most of the videos that I've shown you here is taken from the mangrove behind me and on the beach on the other side of a hill here. This area is a nature resort, shouldn't be touched. Then it's a bird sanctuary, because there is a near extinction doe that lives only here. Then of course it should be protected because of the carbon it binds that is necessary for the climate. But Chinese money trumps all that. You can hear the excavator in the background here. This is going to be a holiday resort. So, tree lovers all over the world, unite.